Oh, are they in the way? Okay, so good morning. It's me again. I'm Joanne Hindo. I'm an IBM Corporate Social Responsibility, and I lead World Community Grid. So we'll do a little bit about me. So I thought rather than talk about my history with World Community Grid, I'll explain my 3 keywords on my Post-it note yesterday. So I don't like sport. I don't watch sport. I avoid it as much as I can. The exception is swimming. I like being in and around water. Saffron is my favorite spice, and I'm a big tea drinker, and very specific tea, really, really, really strong tea called PG Tips, and the Brits are laughing at me. Okay, so World Community Grid is a volunteer computing initiative that runs on BOINC. We specifically focus on research in areas of health and environmental sustainability. Since the program was started in 2004, IBM has been funding, managing, running World Community Grid, and specifically the corporate social responsibility sort of function within IBM. I'll say a little bit more about that, but essentially we're sort of the philanthropic arm of the company, although we don't really do philanthropy. I'll explain more in a bit. But we basically are trying to figure out how can we use technology and IBM skills and talent and expertise to really move the needle on issues that address that our communities are facing, and how do we help them thrive and succeed. So the model that we sort of go for on World Community Grid is that we partner with scientists at research and academic organizations all over the world who are already doing computational research. And typically they already have a research application, some kind of modeling or simulation tool that they're already using, but they're constrained for computing power, and so they come to us for help. And we've done over 30 of these kinds of projects, so we've had all kinds of different research applications running on World Community Grid, from quantum chemistry, molecular dynamics, genome comparison, drug discovery, protein structure prediction, weather modeling, climate modeling, and all kinds of other fun things. So what we do is we say to them, you pick what research application you want to use. We will then integrate it into the World Community Grid platform, and I'll say a bit more about what that really entails and what that means. We will also recruit and engage the volunteers that you need to support your research, and get them, basically recruit them to help the work get done. And in doing that, so through World Community Grid and the volunteers' contributions, each of these research partners gets the equivalent of their own supercomputer for free. So that's the beauty of this model. Our goal ultimately is really to try and push the needle on that research. How do we make scientific progress on these really important, critical humanitarian issues? So these are the projects that are currently running on World Community Grid. This is a bit of an exception. I'll talk about that in a second. So we have a microbiome project that's looking at the role of the gut bacteria in autoimmune diseases, including type 1 diabetes. A drug discovery project on Zika, another one on HIV/AIDS, and one on childhood cancer. We have a molecular dynamics project on tuberculosis, and a project that's looking at identifying cancer biomarkers, which will help with earlier detection and personalized treatment. And the other thing to note is that our research partners come from all over the world. So we've got US, Brazil, UK, Canada, Japan, Hong Kong, and more US. So I mentioned that smash childhood cancer is a bit of an exception. Right now it's paused. So we have periods where the researchers say, give us more time to really look at what results we've produced so far, and kind of figure out the strategy of, in this particular case, which proteins we want to target in our next drug discovery series of batches. So it's paused, but it'll be coming back on soon. And hopefully that wasn't confidential, but anyway. So the other thing that's interesting about this project is this actually started as a collaboration years ago with a group in Japan that was looking at identifying a new drug for neuroblastoma, a really nasty type of childhood cancer. The cure rate for it hadn't improved in over 2 decades. And so they came to us for help, and with the help of 100,000 World Community Grid volunteers, they screened 3 million potential drug candidates, narrowed it down to 7 that were proven in the lab to be effective against neuroblastoma. A huge, remarkable success story here. So successful that they then partnered with researchers in Hong Kong and the US and came back for more in what became the SMASH Childhood Cancer Project, to really use the same methodology, same technique, and apply it to a number of additional types of cancer. So we got a bunch of press attention for it, including this was a press conference with the guy in the middle is the governor of Connecticut, Governor Malloy, and that's the Connecticut-based US collaborator. So for our volunteers, they get to pick and choose which of these research projects they support. So when childhood cancer is pausing, they can focus on something else. They can focus on many projects at the same time. And along the way, they get to learn about the science behind these projects, and they get to engage with the researchers as well. And then for our researchers, our volunteers typically are giving them about 100 times more computing power than they would have access to through their own sort of organizations and funding sources. So obviously that means they get to do this research at a much, much bigger scale. But it's not just about doing more computational research. When you're sort of providing that kind of computational power, it's often unlocking kind of new computational techniques, new methodologies, new approaching to getting the science done. And we've seen that happen over and over again as well. So we're essentially saying to the scientists, you're the experts on the science, you focus on that and let us handle the technology piece for you. So we don't get involved in any of the scientific decision-making processes for any of these projects. We don't define the scope. We don't analyze the results. We're not the ones publishing the papers. But through World Community Grid and our volunteers, we're enabling all of that to take place. Here's what this looks like and means for our research partners. This is Dr. Rob Knight at University of California, San Diego. He is one of the co-PIs on the microbiome project. His other co-PIs are the Simon Foundation in New York and the Broad Institute of MIT and Harvard in Boston. And he describes World Community Grid as being instrumental in making sure that his research is years ahead of where it would be in terms of its progress if it wasn't for the contribution of the volunteers. Another example, this is Dr. Alana Spuruguzik. When we partnered with him, he was at Harvard. He just recently moved to Toronto University. So when we worked with him at Harvard, he wanted to look for more efficient materials for solar cells, and specifically focusing on a specific class of solar cells called organic photovoltaics. They are more bendy, easier to use, cheaper to manufacture, so you can have sort of more exciting applications. So they're not just sort of going to be like, stiff solar panels. You can apply them to flexible materials and so on. The problem is they're not that efficient. So he went out looking for more efficient types of these particular solar cells. He ended up screening about 2 million compounds and narrowed it down to 1,000 that are predicted to double the average efficiency of what's out there on the market. Again, really successful project. But to give you an idea of the scale of acceleration with World Community Grid, typically computational chemists are studying 10 to 20 molecules a day. With World Community Grid, they were going through 25,000 a day. His work got published, the discovery that I mentioned, but won a bunch of awards, got a lot of media attention and accolades, so another success story. I'll mention one more example. This is a project that was a collaboration with Tsinghua University in Beijing, where we were simulating how water flows through carbon nanotubes. And in doing that at the scale at which the researchers got to do this at, because of how much computational power they were provided with, they made a discovery that under certain conditions, that water flow can be 300 times more efficient. And that really opens the door for applications in water filtration and desalination. They published their work in Nature Nanotech. This is actually not their paper. What is even more impressive than their paper in Nature Nanotech is an editorial by 2 world-renowned physicists that really describe just how remarkable this groundbreaking discovery is and the role that World Community Grid played in it. We love to see this kind of validation by experts and leading experts in the field. So over the years, we've seen researchers really tap into World Community Grid, making these kinds of discoveries, and publishing over 50 peer-reviewed papers along the way. Now, not every one of them is as exciting as this example. And the other thing to note is not every one of them is necessarily about scientific advancement. It could also be about the computational advancements. These are improvements in the very computational methods that can help other areas of research beyond just what research, how the tool is being used on World Community Grid. And obviously, the number of publications is one of our main measures of success. That's what we're ultimately looking for. Are these research groups making progress in their work? So what do we look for when we decide whether to take on a research project or not? 4 main criteria. We only work with research organizations that are public or nonprofit. We do not support commercial research for obvious reasons. We also evaluate each proposal based on its scientific merits. So we have a peer review process where the proposals get reviewed by scientists from both within and outside of IBM. We also look at technical merit. So not every kind of computational problem can be crowdsourced and distributed to volunteers. So unfortunately, we sometimes have to say no. We've always had an open data policy, and this is really our way of making sure that the data that the volunteers generate spills in wider than sort of benefits more groups than just the groups that we are partnering with. And then also we want to see that the research groups that we're partnering with, their lab, their department, and so on, have the staffing, the funding, and other kinds of resources to really see this work through to fruition, and to be able to analyze the data and get the insight they need out of it. What do we do? What role do we, World Community Grid, play in this equation? So this is typically what it looks like when we are taking on a project. When we receive the research application, the first thing we do is throw it over to security experts at IBM and say, go and find security holes in this application, because we'll need to fix them before we start distributing this thing to volunteers. So we do a security review. We also look at the license under which the application is licensed, because we don't want to be infringing on anyone's intellectual property rights. We then integrate the application into the World Community Grid platform, which, as I mentioned, runs on BOINC. That includes everything from the I/O calls, adding checkpointing capabilities. We also develop a screensaver, do various levels of testing before releasing it to the volunteers, and make sure that the software is running across our platforms. So we run on Mac, Android, and Windows. Only one of our research applications runs on, Mac, Linux, and Windows, and only one runs on Android. So we don't have Android across the board, but we support the other 3 fully. We also try and automate as much as possible the flow of research tasks and work units back and forth between us and the researchers. We handle everything to do with volunteer recruitment and retention and support. And that includes things like working with the researchers to develop all of the content that goes on the website, to educate the volunteers about what is this project, who is the team behind it, what science methodologies are they using, and what does it actually all mean. We also work really closely with the researchers throughout the life cycle of the project to try as much as possible to communicate on a regular basis with the volunteers and keep them updated on what we're doing. And when they do reach those major milestones and really important papers, we pull in our corporate communications colleagues from IBM to help us get the word out and really raise awareness of the researchers' success, of the volunteers' role in that, and obviously of our role in the work as well. A little bit more about our community. We've had over 760,000 people participate in World Community Grid and contribute results. They've signed on over 5 million devices. You'll notice the ratio is not 1-to-1. That's also because we have over 450 organizations that sign up their sort of corporate or organizational devices as well. I'll mention a couple of examples. We mentioned a couple yesterday. IBM obviously is a big organizational contributor too. Of the 2 million years of computing power, about 8% comes from IBM machines, so employees' laptops, essentially, and then the rest comes from external volunteers and external organizational partners. Oh, the other thing to note is of the 5 million devices, about 60% are Windows, 25% Linux, and the rest is Mac and Android. Okay, a couple of examples of an individual volunteer and an organizational sort of contributor volunteer. So individual volunteer first. This on my whatever, this guy is Dylan. He is a high schooler in Canada, and he decided to configure a bunch of servers at his school to contribute to World Community Grid, and specifically to the cancer biomarkers project that I mentioned earlier. The team for that project is based on the other side of the country in Toronto at the Crumble Research Institute. So when they saw what Dylan did, and they knew about it because he was on TV talking about it, local TV, they invited him over to Toronto, flew him over to the Crumble Research Institute, where he got to spend a day sort of having a look, getting a behind the scenes look at how research gets done and meeting the researchers. Obviously, this one-to-one sort of researcher meets volunteer it doesn't happen very often. I think this is the first time we've managed to make it happen, and actually it was Crumble who really did most of the work here. It's really amazing to see that kind of engagement. Obviously not very scalable, but it's really beautiful to see. Otherwise, a lot of the engagement obviously happens over our forums. We have the project updates that the researchers provide, but this is a really great example of the kind of engagement between volunteers and researchers. And then besides individual volunteers like Dylan, I mentioned we have 450 organizational partners. So this is everyone from IBM. I mentioned another example yesterday. Sony used to pre-install World Community Grid on VIOs they would sell in the US. We have universities signing on their, all of their university lab machines, retail banks, small companies, everything in between. One example is De Vos Bank. This is a bank in the Netherlands that became a fairly recent partner. This actually started off with a couple of employees at the bank who already were World Community Grid volunteers. And they thought, how can we get to really maximize our contribution, and can we get the bank involved? So they started off by installing World Community Grid on a bunch of Androids and some decommissioned server that they had at the bank. And that was kind of a proof of concept that led to them pitching this to their management, getting their management to agree to roll this out across the bank. And today they are the #1 team in the Netherlands. To give you an example of how far some of these partners go, so they would promote us on social media. They've written blogs about World Community Grid and the work that they put into making all of this happen. They also have a recent installation, beautiful installation in their office lobby, I think a week or two ago, highlighting different technologies from wearables and voice recognition and so on. And part of the display is also World Community Grid. So that was really cool for us to see. Okay, let me zoom out for a little bit and talk about where World Community Grid fits in the context of IBM corporate social responsibility. World Community Grid is really part of a portfolio of programs and initiatives under that CSR umbrella. All the intention behind all of the programs and the work that we do is we're trying to make social impact in 3 key areas: health, education and skills, and disaster resiliency. We don't really do much in the education space as such, at least not the kind of education work that the rest of the CSR practice does. But certainly touch on the other 2 areas of health and disaster resiliency with our work in the environmental space too. The other thing to say a little bit about our sort of CSR function is we really are always looking to kind of scale up the work that we do while also deepening the impact and maximizing the impact of the work. And we do that by applying a number of different sort of approaches to how we do corporate social responsibility. So one of them is that we are trying to kind of go through a massive digital transformation of all of our programs, starting frankly with a lot of our programs have been very siloed historically, and we're trying to integrate them. This isn't just about technical integration, but about cross-promotion. So if you are volunteering with another of our CSR initiatives, you probably really want to hear about World Community Grid, then you're likely to want to contribute too. So a lot of that kind of work is starting to finally happen. Another is user centricity. We spent 2 hours on this yesterday with the design thinking work, but really trying to put the end user's need first and foremost, and thinking about the user experience. And I can't say we've always done an amazing job with that, so we're trying to focus on that as well. And agility is another key component, which is, don't try and be perfect, just get it out to your end users, get feedback, and constantly iterate and improve. And then the last is a platform ecosystem. So again, this isn't just about having an architecture that can help you play along with the other programs and other initiatives, but also from a partnership perspective. How do you identify the right partners to bring into the equation to really make an impact on those 3 areas? And if I take World Community Grid as an example, we're not the ones looking for drugs for cancer. We partner with the researchers who are, and we think about ways of applying technology to help move their work forward. So it's really about finding the right partners, co-creating with them, and bringing them into the equation. But that doesn't just mean that we have to go find partners sort of externally. It also, we're starting to do that internally as well. So we started with a bit of an experiment a couple of years ago where we said to researchers, okay, you typically come to us to get free computational power. Well, what if we were to throw in a bunch of additional IBM resources? So we partnered with IBM Cloud and the Weather Company, which is an IBM business, and said to researchers, actually at the time the initiative was specifically focused on climate change and environmental researchers, and said, come and get cloud storage and weather data for free as well. That led to us picking 3 projects. We are finally about to launch the first of those 3. I think this time last year, I stood here and said, it'll be ready in a few months. And the Oxford team is laughing at me saying, we told you so. Yeah, it was a beast. This application was a beast to work with. We're finally within a few weeks of launching. So the first of the 3 projects is the rainfall, is a rainfall modeling project in Africa. And then the other 2 still to come will be looking at the impact of climate change, impact of atmospheric aerosols on climate change, and the impact of climate change on public health in the US. So when we did this experiment, this was a really good way for us to kind of figure out, can this model work? The answer is yes. It's frankly not that easy to pull off, but it's doable. And we want to be able to do more of that. So the idea that we're starting to kind of toy with is, can World Community Grid really become kind of a gateway of giving researchers, computational researchers, access to computing power plus ... We'll fill in the gap based on what internal sort of collaborations we forge and what research needs have, and how can we match those things together to give them access to other IBM kind of capabilities as we go along. I'll stop there for questions and laughing at our year to onboard that project. Yes. What do you mean by collect the data? Like what? So, I mean, we take the input data from the researchers, we distribute it out to the volunteers, we bring, when it comes back from the volunteers, we validate it, package it, and send it back to the researchers. But they define what input data and parameters they want to run through the simulation tool. And then they have to have their own kind of infrastructure on their side to store that data and then analyze it. The analysis piece is more of a scientific process, and so we don't personally get involved in that. But for example, to give you an example, there are groups in IBM that do similar work, and that's part of the ... is can we bring them into the equation to help with the analysis piece, for example. But right now we don't. Yes. Oh, yeah, sorry. Do we have resources that go towards developing BOINC? So Keith and Kevin spend a good chunk of their time, percentage of their time, not just on the PMC, but also with hands-on work at BOINC. And our contributions sort of to BOINC kind of fluctuates over time. And, you know, we have to sort of balance it across and sort of against World Community Grid priorities too. But essentially we have to representatives on the in the BOINC community, not just on the PMC level, but also sort of hands-on level too. Mm-hmm. Yes. I wish. Nothing in the pipeline. So to repeat the question, it was 5, 6, I don't remember how many years ago. Watson beat the top competitor, Jeopardy, and the winnings from that competition went to 3 of our research partners. It was a donation to them. So it was great publicity for us at the time, of course. We don't have anything in the pipeline, but there have been other sort of examples. I mean, obviously, part of the reason why we bring in our corporate communications people to help announce a new project or a discovery is, like I said, yes, raise awareness of the researchers' work, but to recruit essentially other volunteers. So things like the work that we did with Harvard was incredibly successful in really raising awareness of the work that we're doing. We won a Webby Award a couple of years ago. That was really great. We try and do our rounds on the conference circuit, and we've been to South by Southwest a couple of times. So that's the kind of stuff that we do. Nothing at the scale of the Watson thing where we're going to be on TV. No. Nothing on the horizon, at least. Yes.
So, for example, the analysis applications for the timing, are you have you developed essentially a completely end-to-end, very specific application for each of your bases, or is it essentially a more generic application which will then be customized for each? What's the method? So, I say this very to us, but we have a very generic app that goes out and it's all on the scientists to then take the data that generates and answer questions, similar questions. We don't put the analysis for the specific questions into the app before we're actually using it. We get the scientists to do a lot more analysis themselves rather than try and build what would be for those 3 different scenarios.
They are 3 completely separate applications. We would be going through 3 completely separate onboarding processes, integration pieces of work. Having said that, once we do integrate any of these research applications, when the next research group comes along, and if they want to use the same research application, we don't have to repeat that work. Yes, Kevin?
One comment I might be is that the research
do you want to?
Application to us, we don't
we don't write the application. And we don't touch the scientific algorithms in sort of within the application. Where we don't want to screw that part up. On some. Well, do you want to expand on that?
So sometimes with the science application, they'll bring it to us and
Okay, so anyways, so sometimes the science application does come to us and it's written by students at universities and things like that. And we will actually, as we're running it, we'll realize this is very inefficient. One example was that Help Conquer Cancer, they had basically a routine that looped through millions of times. And they initiated a variable and destroyed a variable that wasn't actually even being used. And they did it millions of times. So basically, we erased that and then sped up the program by about 2-fold, actually. So I mean, there's things like that that we'll notice and we'll go, yeah, that needs to be
exception to the rule. but yes, it does happen. Yeah, we've had actually a number of applications being reused and repurposed, and that's why I mentioned we have one application called Vina, developed by Scripps Research Institute in California. It's a drug discovery app. We've had so many requests for that app. That's the one we end up onboarding on Android, because we know it's popular and it keeps researchers keep coming back for more. So we do get a lot of reuse, and that completely shortens the time span of when we can bring a project on board. And frankly, we want to see more and more of that. Any other questions? Yep.
I also mentioned, remember you mentioned some of the computing clusters are not a fit to so what kind of
Yeah, so the kind of the projects that aren't a good technical fit for World Community Grid, either they require more resources, whether it's memory or storage than a typical, volunteer laptop is going to have. Either it's going to be actually probably the most common one is a lot of research applications require communication between the different nodes. Now, volunteers' machines are never communicating to each other. All the communication goes back and forth through World Community Grid. So where you have dependency of one work unit on the results of another, there are ways for us to do it where, let's say, your result needs to be finished before mine can begin. There are ways for us to manage that a bit. But if your computation, while it's computing, needs data from my machine, that's not going to happen. So that's a really common reason we say no to researchers. The other reason, which is a real shame, frankly, is because of what I mentioned a few slides ago about the integration work that goes into integrating these applications into World Community Grid. That process typically doesn't take a year. That this project was an exception, but it does take a few months. And so if a project is coming to us to say, I want 3,000 years of CPU, well, we'll get through a 3,000 years of CPU project in no time. We don't want to be spending 3, 4, 5 months of onboarding a project for it to be running out in a few weeks' time. So we say to researchers, really think big, and we only take on a project of a certain size. The beauty of having more repeatable, if we've already integrated that research application and it's a much shorter life cycle to bring it on board, it then allows us to say, actually, you don't need to be that big. You can be a smaller project and we can still take you on. Am I missing anything about technical fit? I mean, the main ones are sort of computing resources, internode communication, and the size. Yeah, that's a really good point. So there's a lot of computational apps will, for let's say a 5-hour calculation, it's going to take an average computer with average bandwidth maybe 3 hours to download the data and another hour to upload the data. Well, that's probably not a very good, efficient use of these computing resources. We want the ratio of how computing intensive that application is versus how data intensive it is to be much more tilted towards computing intensive. So we want really computing intensive with a sort of a light data requirement. Those are a better fit for us too. Anything else? Okay, who's next, Erica? Thanks.
next is Angelo Crisogiannis with Yummy and Yummy.
Water bottles that were left behind.
Just put on this guy?
Yeah,
Sure.
On this old sheet button.
Yeah.
So this is recording video feed. This one is just.
Is that good? This way? Is there a clip or? Oh, the clip's the opposite way. I'm sorry. I didn't see it.
Yeah, then is there a button you press on the back?
Yeah, I'm not. Should automatically.
So there it goes.
Yeah.
Good morning. How are you? Okay, excellent. So I'm really happy to be here. I got to tell you, I just want to thank IBM for letting me be here because I'm a really crazy, passionate guy about volunteering, and you're going to see that. You're going to see that in the upcoming slides. So let's get into it. Basically, today I'm going to be talking about leveraging the power of the NUC, Next Unit of Computing and Compute Stick. Basically, these are units made by Intel, and I'm not here to sell an Intel product. Okay, so we're going to let's pause for a second and take a bird's eye view, 30,000 foot view of this. Okay, I'm a volunteer. So basically, we're going to be looking at the mini PC family as a whole. Although I'm going to be doing a deep dive into the NUC and the compute stick, want to just keep that in mind. All right. So who is this guy? Who is this guy talking to me today? Basically, the takeaway from this is this. I'm a crazy, passionate Greek guy on two things. Apple products, because I'm a native iOS developer, specifically with Objective-C. Okay, so all throughout the presentation, you're probably going to hear me say a lot of cool things about Apple and how Android's kind of the dark side, but still want to use Android because we don't have Apple products yet. We don't have iOS working yet for BOINC and the IBM Global Community Grid. So as far as me, I have over 60 apps on the App Store. I actually started making apps. I have apps that actually help generate some revenue. I give away money to foundations like for autism and cancer. And that's how it really started. I looked around, Googled it, saw cancer research, and then on 24th of October, I decided to start doing this. I thought this was a great initiative. And you're going to see later how many machines I have because I kind of went bananas. So what do I really do? My day job is I'm a senior iOS release manager for Honeywell Aerospace. I love that job. I love what I do. I like to test. I like to develop for iOS. Develop iOS applications. I like to develop Mac applications and applications for the Apple Watch. The only thing that I'm missing is the Apple TV, and that's coming. So you're going to see that I actually started my own team. It's called Keep Looking for a Cure, and let's get into it. Okay, so here's my personal setup. I'm a little close. Why am I showing you all this? Well, for one, I went bananas with this, right? So I have a lot of machines here, and I want you to focus specifically on the red items. The red items are really the mini PCs of my group. My big guys are the Apple Mac Pro 2006 and 2008. So why do I have this slide up? The slide is up here for a reason, and that is this. We want to kind of lay a foundation of, we're going to compare and contrast all these different units to the mini PC, the NUC, and the compute stick. So what is a NUC? A NUC, simply put, is a small PC. It's an all-in-one PC, small form factor. I got one right here, as a matter of fact. Let me bring it up. Okay. So this is really small. This is kind of like twice the size of an Apple TV, but it's an all-in-one computer, and these have been out for a while, but people really haven't really seen them. So I think it's really important to kind of draw your attention to that because they can be used for volunteer work. So how are they sold? They're sold as you can buy them as a bare bones kit, or you can buy them as an all-in-one working computer. The cool thing about this is there's so many connections to them. There's USB ports. You have multiple ports for monitors, up to 6 monitors on some units, and you can buy one as cheap as $100. Some are actually in the thousands, but we'll talk about that. So let's look at this. I actually have 3 pictures up here. The one on the bottom, the reason why you see the skull on it is because that's the newest model, and it's actually a gaming model. So it's kind of want to tell you that you can buy one for up to you can buy one for around $100, and this is up like $2,000. People are using it for gaming. So basically, the NUC is very, very powerful. But before I keep going, let me stop and pause and say something for a minute. This initiative means a lot to me. My father had cancer, had diabetes. There's diabetes in the family, and I really wanted to kind of give back, but I really didn't know how in a large way. So 21 units running, I don't want to say 24/7, but a lot of time is a lot of heat. It generates a lot of heat, generates a lot of energy, but I think it's really worth it. And you're going to see that as we talk. Okay, so the advantages of the NUC are this. It's compact, right? It's very small. Volunteers can use it because these are actually becoming mainstream. And everyone knows that technology is actually getting smaller and smaller, all right? And the NUC, although it's made by Intel, there are other manufacturers who kind of make a mini PC, and we've all seen them. And I actually have a couple in my arsenal here, if you will, that are made by ViewSonic. So the NUC is great because it has a small electrical footprint, and we're going to go through that later. It's quiet, it doesn't generate much heat, and it's actually mountable. You can mount it, there's a backplate that comes with it, and you can put it on the back of a TV. Okay. So what can we use? How can we use a NUC? It's really a replacement for a laptop. The way Intel actually markets this is pretty cool. If you watch a video on Intel's website, you'll actually see two college girls opening the door to their dorm for the first time, looking into their dorm room and realizing how small it is, right? And so one of them actually pulls out a NUC, puts it down, connects it, and uses it like a laptop, if you will, because really it's got a lot of firepower. And then in the same advertisement, it has this same girl actually going to the computer lab, and instead of pulling out a laptop, she pulls out her NUC, right? So basically, NUC can do anything that really a PC can do. You can do serious gaming with it, and obviously, I'm using it for BOINC. I'm using it for research. Small businesses use it, and you can use it for digital signage. So, really quickly here, I just want to give you the difference between the lower end and the higher end, right? So the lower end, you can go as low as a Celeron processor. The higher end, we have an 8th generation Intel Core i7, which is really good. I mean, and the graphics card is stellar. And these really are pre-packaged with Windows, but you can put Linux on them, obviously. They're wireless, lots of ports. And basically, I'm going to show you how these are excellent little machines to use for volunteering. Just wanted to kind of show really quickly, not going to go over the steps here, but it's super easy to upgrade RAM on a NUC. You really just take out 4 screws, you open up the plate, and you remove the memory. It's that easy. So we're going to, basically this presentation is we're going to fly through some of the slides on what a NUC is and what an Intel Compute Stick is, and then I'm going to explain to you how I use it for research, okay? The Compute Stick is around 2.5 times the size of a USB stick. But the great thing about it is it's an all-in-one unit. And you can just plug this right into your TV. As a matter of fact, whenever I'm on a business trip, I plug it into the TV at the hotel. I turn it on, I go off to work, and it's computing, right? It's actually working on all the projects that I really wanted to work on. And so it's a great thing. And then when I leave, I pull it out. Nobody knows. Put it in your pocket. It's great. So the Compute Stick is very similar to the NUC, but obviously it's smaller, so it's limited in some ways. Really, it's more limited in the RAM. Okay, and like I said before, you can go to Amazon, you can buy You can buy an Intel compute stick. I bought mine off of eBay. I have to admit, I think I only paid $30 or $40 for it. And but I have to admit, there are so many other manufacturers to this type of technology, and they use this. They use this phrase. They interchange this phrase "mini PC" all the time. A compute stick could be a mini PC. A NUC can be a mini PC, which stands for next unit of compute. They have other little desktop devices that kind of look like cable boxes that they call mini PCs. So let's kind of think about that as a volunteer. Let's just think about that group of products, okay? So an Intel compute stick, like I said, it's all in one. You really can't upgrade it. Has the HDMI port built in, Bluetooth capable, micro SD card slot, and USB port. I really fell in love with this product. I'll tell you why. It's so small. The electrical footprint is so small on this product, and it's fabulous. The internal RAM is 1 gigabyte. You can buy, that's the lowest unit I've ever seen. You can buy them with more RAM, but that kind of precludes you from doing super intensive calculations. But anyways, great product. So what do people use this for? Same thing, a little bit lower, more or less, how should I put this, lighter in the general computing area, right? It's great for presentations. You can put it in your pocket, right? And you can take it wherever you want. People use it for thin clients, digital signage. So whenever you go to the mall and you see a sign and you're like, hey, how is that thing working? Is there a PC in the background? What is it? It could be this. It could be a compute stick. It could be a NUC, right? And I love to use it for BOINC. Use it for volunteering. And obviously you can surf the web. So again, if you're at your hotel room, you can pull it out, plug it into the TV, surf the web, you're golden. Okay, lastly on the compute stick. Let's look at this. The lower ends, you're using an Intel Atom, right? And the Atom processor family is used a lot. And in the higher end, you can actually get an Intel Core M3 processor. You can have 4 gigs of RAM, 64 gigs built in of storage. Wireless is built in, USB, you have your Bluetooth. But it can get kind of cumbersome to want to actually use the stick and say, oh, I want an external keyboard. I want to use an external mouse. So what do? Well, I'm going to show you what you're going to do later. It's going to be pretty cool. Okay. And we have technical issues. Give me a second. Okay. It's dying on a specific slide, so 1 second. Doesn't want us to see the slide. I don't know why. I'm going to try. Yeah. I'm going to try one more time. We got it? Somehow it's chopping off the top, but okay. So basically the top says job load per device. Is it? Okay. Okay. So let's look at this. We're gonna basically do a deep dive, and you're gonna see what I do a little more. Okay. So the job load per device, really I'm meaning the work unit, right? So what does this mean? Basically what I want you to do is look at this side of the graph, which would be your left, okay? When you get to this spot here is my bad boy, my Mac Pro 2008. It's a beautiful machine, okay? From here, from the beginning to this spot here, all these items here are actually mini PCs. The first one on the left, are actually ViewSonics. Okay, they're older. Then the third one is my first, really, it's kind of an old NUC. The next one is my newer NUC, and then I have my compute sticks and my new compute stick. So what am I trying to say here? What's the takeaway? Here's the takeaway. I have 4 work units running at one time on my NUCs, on my mini PCs. I'm comparing them to the right side of the graph, which are my laptops, my desktops, my towers, my Mac Mini, and my Android tablet, right? That looks great. These are little computers and they're doing great. They're actually being able to run 4 jobs. And so how did you make this graph, you're probably thinking? I took the same job, work unit. I took the same work unit, which was from the microbiome project, right? Making sure they're all running the exact same work unit. I have these running at 100%, meaning all cores are firing, and it's 80% maximum CPU. So this is what the chart is based on, and they're doing great. Okay, this is where it gets a little bit crazy. I have my bad boys here, my Mac Pro 2006 and 2008, and if you've ever seen these machines, they're gorgeous. They're huge, brushed silver. See, this is where the Apple evangelist comes out in me. Okay, but here's the problem. They're power mongers. They just eat up so much energy, and I learned so much from doing this presentation, because now I'm thinking, do I want to keep doing this with these machines? 980 watt power supply. So you're probably telling me, why are you looking at power supplies? Power supply, when you look at wattage, the power supply is really the maximum wattage, right? Fine, 980 watts. But again, like I said, this test was 100, all cores are firing, and each CPU, according to the BOINC configuration, is at 80%. CPU can only can't go past 80%, right? So look at the footprint in the footprint as far as electrical footprint. You have the compute sticks here, practically nothing. I think I'm at 10 watts per compute stick. It's nothing, okay, compared to some of these other things. Here's my old Dell tower. And again, you're probably saying, why do you have so many devices? Well, I have a lot of devices because basically I repurposed a lot of these. I kind of took them saved them, if you will, from the Goodwill shelves, right? Because I thought, if it's sitting around, why have something sitting around and not turned on if it can actually help research, right? If it can help, and specifically, like I said, I like to do cancer research or research for diabetes. It's close to my heart. But I've opened it up to all research, right? Because as the previous presenter said, the Android tablet can't do anything other than OpenZika, right? So this is my chart for power consumption. Again, the mini PCs are doing great. Okay, so you can't see the top again, but the top of the graph says power and job length, which really means power and work unit length. Okay, so this is what we're going to look at. Again, I took the exact same work unit from the microbiome project and basically showing you the watts, how much I'm using, and you'll see a number here, and this is what it says on your screen when you bring up a microbiome work unit that needs to be crunched, right? So for instance, the Dell laptop says it needs 4 hours, 58 minutes, whereas in comparison, the Mac Mini dual core would need 3 hours, right? So let's look again at your left side of the screen. You're going to see the 2 ViewSonic units, which are basically, for lack of better terms, they're kind of like NUCs. They look like cool little cable TV desktop boxes, right? But then after I did this presentation, I realized how not cool they are. Okay, so and you're going to see it later. So I learned an awful lot. So the NUC is the third item. Okay, so NUCs are around 65 watts. So people who really know about power, and I know that there's a presenter later in the day that's going to have much better charts than I am, I'm sure, because they're going to look at power and heat. But okay, let's be logical. A laptop's going to take around 65 watts, right? A tower is going to take more wattage, right? And that's why my Mac towers can actually take 4 graphic cards, 980 watts. So what are we saying here? What are you getting out of the slide? Still doing great, right? 10 watts for the quad core compute sticks. They're quad core sticks. Yeah, they need 7 hours and 40 minutes to run a work unit, but it's running at 10 watts. And you're probably saying, well, Angelo, again, 10 watts is the maximum. So what are you talking about? Are you really using the maximum? Are you using the maximum here? Are you using, what, 350 watts for your Dell tower. That's key. We're going to look at that later. Okay. So now we're going to look at power. Why am I doing all this? As a volunteer, I say to myself, hey, I have a lot of units. And oh, by the way, I didn't mention, I live in Arizona. It's hot. It's the surface of the sun, right? So if I have 21 units at my place running at once, how much heat am I generating? I mean, these are some of these units I'm going to show you later would be great heaters in Chicago, okay? And that's when I'm probably going to have to end up retiring. But specifically for the heat output analysis, I looked at 3 compute sticks, 2 Intel NUCs, and 2 ViewSonic mini PCs. Why am I looking at the mini PCs, the ViewSonic ones? Something to compare. Compare and contrast. We need to compare and contrast something, right? So to the Intel compute sticks and the NUCs. So this is what I did. This wasn't something that I was going to really do until I kind of burned my fingers, if you will. And I thought, I have to kind of put this slide in, although it's kind of like a 6th grade science project type of a slide, okay? Because I really just had placed a thermometer 1 inch away and 2 inches away. And I'm giving you the manufacturer date. So you're probably saying to me, Angelo, what type of thermometer did you use, right? I'll tell you what I did. Like many geeks, right? We take on the challenge. What do? Well, we look in our closet and we look at all our cables. We look at all our stuff that we have that we've compiled over the years, right? And I had an actual thermometer, digital thermometer with digital readout for a gaming PC. You know, the gaming PC that everyone wants to make, but we never do, right? And so you have it in your closet. So I pulled it out and it took, long story short, it took a Molex connector, a standard Molex connector for power. And these powered connectors are really, you know, kind of old school now because we have the SATA drives. So I had to find an internal power supply to make it external, right? So that I can connect this thing and walk around the house and put it 1 inch away from different units or 2 inches away and take readings, okay? So I'm kind of proud of that because, you know, as a geek, you walking around the house with cables just following you. That's cool, right? I mean, that's the cool part, right? So I had a lot of fun with this. So why am I showing this slide? Because the compute sticks, although they do get hot, the ViewSonics got hotter, okay? And 2 inches away, this isn't that bad. 2 inches away being 87 degrees or 95 degrees, that's not bad. 111 degrees, that's bad, okay? And these ViewSonic guys here, 4 inches, 4 by 4 inches, if you kind of make a cube around the fan, I'm talking about a gust of wind here, not good. So definitely candidates to retire here. So from a heat perspective, not generating much heat. Why is that important? I'll tell you why that's important. I have 21 units running. A lot of them are running 24/7. So I don't want to generate heat all day, right? That's very important. So again, this is just another way of looking at it. Gets really hot. Not good when it's hot, right? Again, perfect candidate for the wintertime in Chicago. If you want a ViewSonic, go for it. Okay, 1 second. Okay, so we've already talked about the fact that I have things running at 100%. All cores are firing. 80% is the highest the CPU I'm allowing the CPU to get. Okay. We talked about CPU stuff. We've talked about CPUs. We're going to talk about RAM. We talked about heat. We've already talked about how small these units are. Fabulous. You can put some in your pocket. You can put them in your backpack if you're a college student. So what does that tell us? That tells us now that we need to talk about configuring a NUC, and I'm going to show you how to do that. Okay. So I never, regardless of the OS, I never really let my items sleep. I never configure them so that they can go to sleep ever. Okay. So, because I want to give as much as possible, right? Maximum power, maximum efficiency, minimum power, right? So, let's see what it says here. Okay, so basically what I do, one of the key things I do is I actually have the BOINC client configured for startup, okay? And yesterday, when we had this awesome get-together at the end, we were talking about cool things that we can do with the client, what we could do with the client, what we should do with the client. When you take the BOINC client and you actually configure it at startup, that's awesome for a volunteer, because you're turning on the computer, you're turning on the compute stick, and it starts. That's a no-brainer, right? That's like that's a slam dunk right there. That configuration is slam dunk to do that. So, and then later we're going to talk about running headless. Okay, that's very important too. So how do I set this up? We're not going to go through all the steps here. This is just for reference. Okay, so basically, I'd like to give a volunteer just an understanding what I do if I want to make a dedicated unit run crunch numbers for whatever project you want. I always talk about cancer during this presentation, but there's a lot of projects, right? That's just close to me, and so that's what I pick. So what I do is I give my computer a name whenever I start it. I configure it so it doesn't ever go to sleep. And the key thing for me is I use this accessibility on-screen keyboard. Why is that helpful? Hello, 21 items in the house? Do I really need to go buy 21 keyboards? 21 mice? I mean, that's a lot, right? So what do? I actually take the on-screen keyboard and I put it in the startup drawer as well. So now when you start up the unit, no matter what it is, laptop, Mac Pro, compute stick, NUC, it starts the minute the computer starts. The on-screen keyboard will pop up and BOINC will pop up, right? IBM Community Grid will pop up, right? And I'm set, right? So when I first start, I download Windows updates, it's forever. I wait for that to occur, and then I download and install the BOINC client. I think it's important. So what if I want to use Linux? Use Linux. People ask me, well, you got 21 items. How do you get this? You must be crazy. You know what I do? I'll put Linux on a USB stick. I put Linux on a USB stick. I plug it into my laptop or my NUC. Guess what? I don't have to mess with the NUC or whatever you have. You actually install the Linux on a USB stick, put it in. All you got to do is set the BIOS settings to actually fire from the USB stick before the hard drive. Once you do that, if you wanted to really volunteer and use your machine like 24/7, it's going to boot off the Linux drive, the USB stick. It's going to run the client. It's going to do what you need it to do. At the end of the day, turn off the computer, pull out the stick. You never messed with your hard drive. You never messed with any of your personal stuff. Very easy. How much compute stick cost? $6, $7 at Walgreens. It's not going to cost much at all. So that's one way of being a volunteer. If you want to do a deep dive and you're really kind of geeky and you like Linux or you want to try Linux out, Red Hat, Ubuntu, whatever, this is a way of doing it. Okay. So what did I say before? I'm not going to go through these steps. Add the BOINC client. Oh, it doesn't say at the top. The top of the screen says adding BOINC client to startup. Add the BOINC client to startup. That's it. Key. Okay, and the top of this screen says adding on-screen keyboard to startup. Okay, so two things. Add the client and the keyboard to startup. And why is that helpful? Because then we can run headless, right? If we can run headless, so people are probably saying, Angelo, what is headless? Headless is this. You start the machine up, let it start, right? Pull it out of the monitor, set it down. All you really need is like a mouse, right? Because the on-screen keyboard pops up, the client pops up, starts crunching numbers. So now you don't need the screen. That's what it means to run headless. You're not using the screen. You're not using a keyboard. So going back to our power slide before, if you will, I'm not using a keyboard now. If you think about using a monitor now, I've taken back that energy that I'm really kind of using. I'm not using the maximum energy, if you will, of the power supply, because it's just sitting on my desk. This little guy's sitting on my desk and he's crunching numbers for research. I mean, how cool is that? I mean, if you were to buy 3 or 4 of these, I mean, I'm not going to knock it. There's people who like to take walks for research, and that's great. I've done it. You want to give money to research? I've done that. But To buy 3 or 4 of these on eBay for $30 and just have them sit on your counter and crunch, it's a quad core unit. It's mind blowing. I mean, that's awesome. And these are just going to get more and more powerful. Again, I'm not here to sell you on Intel, but there are other compute sticks. There are other mini PCs. Run them headless. And it doesn't bother anyone. Plus, like I said before, I have 21 units. Do I really need 21 monitors? I actually tried to go to Walmart and buy HDMI adapters to flip between 21 item devices. I mean, that was just crazy. I thought, wow, what are you doing, right? Like, why? So, plus I was running out of money, so, okay. Okay, so now we do a deep dive into the BOINC configuration, BOINC manager configuration. I want you to look specifically, I kind of outlined these 2 boxes. When we do research, when we volunteer our computers, our units for research, the biggest thing that I look at is the deadline, right? And time remaining. So keep that in mind. Why do I say that? You're a beginning volunteer or you're an advanced volunteer. Don't get really like hyper and start to like download all these work units, because then the deadline is going to be the deadline. You might not be able to make the deadline. That's not good. Okay. We want to be practical. As a volunteer, you want to know, you want to kind of stop and think sometimes, all right, am I really going to have this computer running dedicated? Am I going to have this unit running half the time? Kind of think about that before you start messing with the configurations. Okay, so keep that in mind. Oh, by the way, I don't know if I said this before. 21 units running most of the time. I started in October 2018. I'm already up to 4 years, 334 days of volunteering my compute time. I think as far as points go, it's like 3.6 million points. So my goal is, personal goal is to try to get the compute time up in my age, okay? But again, if you have an Android running 24, if you have 21 Androids running 24/7 for 8 months or 9 months, obviously that's different than my bad boy Mac Pros, right? So I understand that. So this is the BOINC manager configuration. What did we talk about before? We said that after your computer goes through the CPU benchmark phase, yeah, so it does the benchmarking first as a volunteer. For people who really want to know about this, because it's not like I'm trying to make this complex. When you start off the client says, hey, I want to do a benchmark on your CPU. Okay, so let it do its benchmark. The deadline with the tasks in these projects are normally 10 days, because I focus on the IBM community grid projects, and normally they're on 10 days. That's that's what I've seen. Try to estimate as long as you have on the device before you start messing with configuration. Okay. So, BOINC manager client configuration. This, like everything that I've been doing and researching and just making these slides, and it just all kind of boils down to this, right? It's very simple. People at IBM know what they're doing. Okay, trust them. Why do I say that? The default is at 60%. You want to go beyond 60%, you can do it. Okay, that's fine. But we're going to talk later that I'm going to talk more about it. But having run 21 devices since October, if I'm over 80%, I've already fried 1 unit. Okay, so trust smart people who've made the client. Default at 60% is golden. You'll do great, whether you're a dedicated device or you're running it sometimes. Okay, so what do I recommend when you're configuring this? As a volunteer, I recommend to double the days of work, right? So just double it. So you're going to have a 1 day of work, if you will. Okay, why do I say that? Again, 21 devices, Arizona, hot, electricity, expensive, right? So if I just download what I need and have it, I don't really need to have the unit, the computers, the NUCs, the compute sticks. I don't need to have them on the internet. I mean, they need to be when they're done with their work unit, but they don't always need to be on the internet, have network connectivity, right? That was strategic for me. I don't really touch the whole, let's just talk about this really quick. The network tab, I don't really touch, okay? I don't see a reason why to touch it. You know, if you, what did I say here? If you configure storage strategically, then download happens in a batch. So I don't touch this. Doesn't mean you shouldn't. I just don't. I haven't found a need to it. Okay. So we talked about CPU. We talked about footprint. Talked about electrical footprint, footprint of the physical footprint of the device. But I didn't really talk much about RAM. Why? Well, I'll tell you why. My buddies, the Mac Pros, 20 gigs of RAM, which can go up to 64 gigs of RAM, bringing up the system monitor. I have Red Hat Linux running. I have Ubuntu Linux running, 14.0, 18.0, have Windows 10, Windows 8. I bring up all these, the task manager, and I look at RAM. And what does it tell me? Anything that I have, any machine that I have that's 2 gigs or more, the client, again, the smart people who made this, it's not a big footprint when it comes to RAM. So I didn't really see a need to touch any of this. There was just no. Now, if you have like a compute stick and it's below 1 gigs, okay, then we could talk. But I didn't really need to even put up a slide because I realized that RAM from the client was really like 0.1 gigs. Those are my statistics. So I didn't even touch this. Okay, lastly, what did I learn from this, making this presentation? That I don't use this slide. That's what I realized. Okay, and you know why that's good for me that I realized it? Because I have 21 units. This is awesome. This is awesome because it's a daily schedule. And if I know that I'm going to be working Monday through Friday, right? I can tweak this and have my machines do what they need to do based upon the schedule. Genius. It's genius. So I need to use this. That's a takeaway from me. Okay, so zipping through this, here are the device profiles. Minimum impact, maximum output, standard, power saving. What does this mean to me as a volunteer? Okay, here's what it means to me. Standard is great. Stick with standard if you ask me. Maximum, what is maximum? Maximum is all cores firing and the CPU at 100%. Okay, well, work for Honeywell Aerospace. I love my job. I used to work for General Motors. Aerospace, cars. Let's think about this. If you're running your Corvette, throttling it, maximum throttle, or you're an airplane, maximum throttle, how long are you really going to last at 100%? Not the greatest thing to do, right? Even you're not the greatest thing. If you're doing some benchmarking, go for it. But maximum output, I don't touch. The minute you touch anything on the previous screens, the minute you touch anything, change something, then it's basically you've overridden and you've already kind of made your own custom profile. Oh, this is a custom profile that is saved, so to speak, as a web profile. But I'm talking about, you know, once you change something, you're already customizing it. Power saving, I haven't touched. Minimal impact, I haven't touched because, like I said, I found 60 as the golden. 60% is golden. So, what's next for me, right? Tell you what's next. I was thinking about looking into what's the difference between Ubuntu Linux, Red Hat Linux versus Linux or Windows on the same device, right? Would I get more out of my machine as a volunteer, right? If I use Linux in comparison to use Windows 10? Food for thought, right? And since I'm so crazy about this stuff, because I really am, I thought, how cool would it be to use something old? Can I use my Commodore Amiga? Can I use my Commodore 64? Probably not. So I actually thought about this. This is a little wacky, I know. But let's think about this for like 1 second, because I know it sounds wacky. But we're using an Android tablet for OpenZika, right? Okay. I could put Linux on them. There's some Commodore Amigas were shipped with Linux, or Unix actually, System 4, System 5. But even if I got it to run, could I do it? Well, it goes back to one of my slides that talks about the deadline. could it finish a work unit? Whether I got it running or not. If it can't finish a work unit, what's the point, right? But I thought it would be cool to do. And if I do get it to run, and I'm allowed to speak next year, and it's in Chicago, I will bring it. I will bring my Commodore 64, and I will run a work unit. Not the most efficient, okay, but I think it'd be cool because we're geeks and that's how we're cool, right? So basically, the next thing on my list is I'm really passionate about Apple, right? I'm always talking about Apple. I like everything Apple. Why don't we have the client running on an iOS device? I'm a native developer. And I've already talked to people here at the conference, at the workshop. They've explained it to me, but I'm hard-headed. I'm a Greek guy. And I'm like, somehow we got to punch a hole through this because there are so many people that have iOS devices. It's sick, right? So another thing, Apple TV. Apple TV has its own OS, okay? iPad, as of this year, has its own OS. Is that different than iOS? Apple TV is different than iOS. Why can't we have the client on Apple TV? It looks like a NUC, right? It's as big as a NUC, smaller than a NUC. So why not? So these are some of the things that are kind of floating in my mind, right? Because as a volunteer who's already gone bananas and gone out to Goodwill and purchased all these things, taking these things out of the closet, firing them all up, making my place look completely crazy, I have to admit I'm having a lot of fun, and maybe there are some other units in my closet that I can actually use. So that's this, right? Before I get into questions, I just want to thank everyone for the opportunity to talk. And I want to thank my family for being here. And I also wanted them to thank them too, because 21 units running in the house, 3 teenagers who like to play video games. You know, Dad's heard this following phrase: Dad, I can't use the internet. So, right? So that's pushed me to actually get as efficient as I can with my 21 units. How do I run them without the internet? Can I do this? Oh, okay. How do I run this without the office getting so hot? My spouse is saying all these things, right? So they think I'm mad. Probably am. But anyways, as far as questions go for this, I kind of, before we go into questions, I kind of want to say the NUC is a great unit. The Compute Stick is a great unit. You don't have to get it new. You can get it used. But as a volunteer, I just want to challenge people out there. Use what you have in the closet. You don't have to buy a new unit. If you have an old PC, use it. If let's say you're your own boss and you have your own laptop, and people get all wacky about this power usage thing, right? You have your laptop on. You're going to go to the washroom, or maybe you'll go talk to someone in manufacturing, or like say if you're your own business, you're going to talk on the phone. Hey, Clue phone, your power's already on. Your laptop's on. Turn on the client, or have the client already started so that when you're working, it's working because you're already paying for the power. The screen is on, so I kind of don't really like to hear, oh, hey, it's going to cost me money. Well, your computer's on, so sorry. So as far as questions go, who has any questions? Yes. How do I engage? Well, right, and how did I engage? That's the first question you had? Okay, so how I engage. So I have apps on the App Store that have to do with breast cancer or autism, and so I take proceeds from that, and that's how I started getting to this. And my father ended up with stomach cancer, which he beat, and I started saying to myself, there's got to be a way I can help. And I'm not new to research. I went to the University of Illinois. Here it comes. University of Illinois, Champaign-Urbana, and I have done research at the National Center for Supercomputing Applications. So I kind of know about research. I've done it. I like it. I thought, hey, this is cool. I really look up to researchers, right? So that's the first thing. That's your first question. Answer your first question. Second question was, how can we really get this going, so to speak, with more people? Is that what kind of reach more people? We talked about this yesterday in a situation with Evan and Raphael, who basically, by the way, I have to say, they kind of completely changed the way I think. And I wish they were here to say that, because from that perspective, we really need to get more visibility. I got my hair cut before I got here, and the lady looks at me and says, "Where are you going this weekend?" Right? And I'm telling her, "This is what I do on the side." And she says to me, "Are you for real? Can I really do that?" So to answer your question, we need to get the visibility out there somehow. I don't want to have to Google and go through pages and pages to find IBM Community Grid, if you will. I want it to be, we needed to somehow have a different, or not different, more marketing. So that's why we were saying yesterday when we were talking in the groups, the big companies like Apple, like if we could get Apple, we get it on the iOS platform, Google, we need to kind of have some more of these big companies to kind of push it, right? IBM is great, and it's a big name, and I used to work for IBM as a matter of fact. And so when I turn to someone as a volunteer and I say, "This is safe," because people ask me, I tried to talk to General Motors about this. I said, "This is safe. The client is safe. This is by IBM, smart people." Okay, so we really need to get it out there somehow. And I don't know if it's the word of mouth, but I think the internet is so vast. Maybe YouTube videos. We just somehow have to get it out there. But maybe having some of the bigger companies talk. Any other questions?
I have a similar question. Do you have any like website or information to tell Mr. college students or high schoolers how they can contribute? I think this is a fantastic presentation.
Oh, thank you.
I think that's one way how we can recruit, the volunteers in
Right.
much broader ways.
Right.
So to tell them how they can contribute. But on the other hand, that's my second question. I also want to understand that in the simplest term, in terms of for the low end device for some starter to start to contribute, how much would it cost? What is the lifetime? How much additional electricity bill they need to
Right.
pay because as part of their parents need to know.
Right.
I think.
Well, I can answer a lot of those right now really quickly. So your first question, the slides will be available. Yes, I do have websites. My ID is Greek Scorpion. I'm Greek. I live in the desert. Get it, right? So my team name is Keep Looking for a Cure. I have a website there, but these slides will be up. But to really answer your question, that was part of what we talked about yesterday in the groups. We need some way, some type of a vessel, if you will, whether it's BOINC University or something, to kind of have a centralized location for self-service pages or videos, stuff like that. I think there are already videos out there, but we really have to talk to the community more about that. Second question you had, Android tablet, and I did a lot of research, right? Android tablet, 7.5 watts. Compute stick, 10 watts, right? So from a college student perspective, 7.5 watts or 10 watts in comparison to a laptop, which is 65 watts standard-ish, right? Unless you're talking about a gaming laptop. That's not bad, right? Now again, Android tablet can only do the Open Zika virus stuff right now. Okay, contributing. Compute stick, quad core. That's perfect for a college student. NUC is perfect for a college student. So then they can go back to their parents, and I'm one of those parents because I have a kid going to Arizona State this year, and so I'm going to be asking the same question. Although I was going to give him one of these bad boy Macs, but after I see my own graph that's at 980 watts, yeah. So I would say something like, a compute stick or a NUC. It's not going to cost you much. And eBay is great. Another question? Yeah, I don't know what I've heard. Who could talk towards that?
Well, the thing about the iOS is that Apple's or their terms of service or whatever, what it's getting into it actually says that you can't download a secondary binary
Oh.
and execute it, which is how the one client works. I know there's workarounds and other ways to possibly get it to do that, but from a point standpoint, you want to be able to download the application so there's an update. You don't want to have to actually say, I want to update the entire application to have it already pre
And that's great. We just need to get it mainstream. You know, as an iOS developer, I'm going to actually sign up to be part of the beta developers for the Mac, because I think I saw an email on that as a BOINC volunteer, right? But I deal with Apple working for Honeywell as a release manager. I would love to talk to someone and actually break a hole through some wall.
Well, I mean, yeah, that's what I would like to say is that, you know, the other aspect of it is that people have looked at the terms of service and seen that it's a hard fight to fight, and nobody's had the resources to fight that wall. And so if you have connections, you have the skills, we would support the fight.
Oh, I would totally support the fight. I mean, I'm Apple bananas, trust me. And they make fun of me at work for it, but that's okay. So yeah, I would love to do that, because really, what are we really punching a hole through? For what reason? It's for helping humanity. Well, it's the best thing. I'm sure Apple would be into that. I think they just have to, like I said, punch a hole through their APIs. That's it. Give us an avenue. But yeah, that would be fabulous if we could do that. That would be great. Any other questions? Yeah.
I'm not a person who really does.
Sure.
I was told by someone who also recommend to buy the Raspberry Pi.
Oh, the Raspberry Pi?
To support some mining, like computing mining for some blockchain-based projects. So what's the difference?
So you can use Raspberry Pi, right? You could just put Linux on it, right? Correct me if I'm wrong. And you can put any flavor Linux that you want on it. But that's like, you got to be a little more hardcore to do something like that, right? I mean, you can do it, right? Because you can run a lot of stuff on Raspberry Pi. But as far as like mainstream, you know, I think we really, as volunteers, and especially going through, you know, this excellent workshop that we're at, we really need to try to get the word out more to the common person to try to get, you know, the client. But yeah, you can use Raspberry Pi. There's a lot. You can use anything you put Linux on. We'll try to put on a Commodore Amiga, you know.
But
Efficiency-wise, I think the power supply on the Raspberry Pi would probably be like,
5 watts.
yeah,
New ones are 10 watts.
there you go.
They have HDMI,
But then the question is, after that, if you remember my chart, how many cores? I don't remember what a Raspberry Pi is running off. I don't know if it's running off the Atom family. I don't know what. It's an ARM processor. So I don't really know how many jobs or work units, if you will, it can run at once, right? So that's what you want to look. You want to look at the power consumption and kind of put that up against how many work units.
The other thing about the Raspberry Pi is that they are soldered machines, so you can't upgrade the memory. So like on the nuts, say, okay, I don't have 2 gigs of RAM. I need 4 gigs to run this work unit. You can buy a $30 worth memory chip and insert yourself, you're good to go. Raspberry Pi, 45, that's
The RAM's soldered right on board.
it's soldered on the board. The new one that they just released last month has goes up to 4 gigs. And actually, mine got delivered to my house yesterday.
So you know.
I know about that, so I'll be playing with that one more. But anyways, it's you can't run up the full process at once, but yeah, you're limited on memory. Version was a lot. Yeah, it's $35 just for the itself, but then you have other parts that go with it. So it's $75 investment.
Yep. Any other questions? U of I?
Yeah.
Right? All right.
Not a question, but talking about the level of enthusiasm. You know, if someone's looking to do this, I just went on my tablet here to search on Google and try to see if there's no weird bias in this. And, you know, I typed in, how do I help with cancer research?
Okay.
How do I help with secret research?
Okay.
How do I search for pulsars on my PC? I didn't see anything on the front page that had one on my. Curious.
Well, I mean,
Maybe we need to do
the volunteers, like as a volunteer, I make my own web page, right? If the volunteers made their own web page, and now, thankfully too, which is awesome, my company Yummy Yummy actually became a partner. But when you have the partner pages of the web pages of partners, and that's one way of getting the word across. But that's kind of archaic. That's kind of like the beginning of the web. I remember at NCSA, that's kind of like the late 90s when everyone wanted to kind of have like a ring of web pages. That's kind of not the way to do it, right? So we could do it that way, but you're right. You have to have some type of the search engine's got to pick up on this. The crawlers need to pick up on this.
when I don't know how to install car, I type it in, hey, how do I do this? Boom, I can find a video on YouTube. And it's
Exactly. Exactly.
there should be something similar to that.
So there's definitely a need there that needs to be patched. Yes, sir. Yep. Yes. Yes, a lot of them do. Yep. No. Correct. I don't have data on how to expect the lifespan, other than the fact that I know that I've fried some things. But to answer your question, really, I'll just jump to it. The Android tablet runs 24/7, 7.5 watts, runs 24/7. It actually runs when the screen's turned off. But then on the flip side, how much is it really doing? I talked to someone earlier in the here, and they had said that Android tablets don't really. There are not really that many Android tablets out there, I mean, that help as much as some of the other items. But I don't have any long-term, which that would be great from either side to say this is what I should look at. But what I can tell you as a takeaway is if you stick to the 60%, you're going to be good. The NUCs, I'll tell you really quickly, the NUCs and the compute sticks, the problems that I've had specifically with the compute sticks, they're running Linux, 1 gig of RAM, but I'm not doing anything else but running the client on it. I'm not saying there are any memory leaks, but every so often I have to restart the stick, okay? And I don't know if that's because it's Ubuntu Linux or because it got too hot, but it's that's normally what happens. And that's because I'm running them at 80%, all cores firing, right? But yeah, that would be a great metric to have, is to say, hey, Angelo, when did your computer die? And how long did you have it running? So unfortunately, I would probably have to take some things down if I wanted to throttle things to get some metrics on that. But yeah, I could start on that. That's really good to know. But the good thing that came out of it, lastly, is that the 60% really took me. 80% was what I was doing at, but 60% is great for the average user. Anything else? Questions? All right. I know I've gone over. Apologize. Thank you for having me. I love doing this stuff. Great.
So I think we're going to take a short break now, 15 minutes. So everybody can be back by